Ever try to grab something online and feel like you're hitting a wall, like you're trying to collect some data, for a project, or maybe you're trying to see something that's blocked where you are, or even just trying to keep a bunch of connections open without anyone freaking out?
Yeah, totally. It's tough because the internet's this massive thing, right? But actually getting what you need, like when you need it, can be a real maze. If you're doing research, coding stuff, or just need to get into that data online, having the right tools to sort of break through those barriers is huge.
So that's what we're getting into today, using proxies in Python.
Yeah.
We're basing this whole deep dive on an awesome guide from Rebrowser. Think of it like unlocking a secret level of web skills.
Hey.
We'll start with the basics, like what even is a proxy, and then get into some really slick techniques to make your life easier.
Exactly. The goal is to give everyone listening a rock-solid understanding of how to actually use proxies in their Python projects.
Mm.
We'll break down the different types when you'd pick one over another, walk through the actual Python code, and even get into things like automatically switching between proxies.
Oh,
Then we'll cover how to deal with things going wrong because, they do, and even how those fancy modern proxy services can make everything smoother. Plus, we'll sprinkle in some real-world insights from, the devs who are out there doing this every day.
okay, so let's rewind to the very beginning. What is a proxy, in the world of web traffic?
Yeah.
Imagine you're going to a website. What normally happens, and how does a proxy change that up?
Okay, so normally when your computer wants to connect to Facebook or whatever, it sends a request directly to that website's server.
Right.
The proxy server is basically a middleman.
Okay.
So your computer says, hey, proxy, I want this. And the proxy is like, okay, I got you, and passes it along to the website. When the website replies, it goes back to the proxy first, and then the proxy sends it to you.
So it's kind of like a translator, right? If
Yeah.
you're trying to talk to someone who speaks, Klingon, you send your message through a translator, and they send their reply back through the same one.
Yeah, exactly.
Makes sense. Now, this Rebrowser guide mentions a few different types of these translators or, proxies. What are the main ones we should know about? And more importantly, when would you pick one over the others?
That's the big question, right?
Yeah.
The guide digs into several key types, and knowing what they're good at is super important for making the right choice.
Okay.
First up, we have HTTP and HTTPS proxies. These guys are specifically designed for web traffic. HTTPS, as you probably know, adds encryption between you and the proxy, which is always a good thing for security. If you're doing general web scraping or just browsing where you want a bit of privacy but don't need to be like a ghost, HTTPS proxies are often a solid starting point. They're usually pretty easy to use and give you a good balance between speed and how much they cost. Would you say that fits with some of the scenarios we talked about at the beginning?
Yeah, definitely. Just needing to change your location, for basic stuff, that seems like a solid place to start.
Right.
What's the next step up?
Next are SOCKS proxies. These are more of a all-rounder.
Okay.
They can handle almost any network traffic, not just web stuff. So if you're working with things beyond your regular browser like FTP or even some gaming things, SOCKS might be the way to go. However, setting them up can be a little more fiddly compared to HTTPS. Do you ever run into situations where that extra flexibility would be helpful?
For me, not really, but it's good to know they're there for more complex situations.
Absolutely.
Now, the guide also mentions residential proxies. These sound kind of sneaky. What's different about them, and when would you absolutely need them?
So residential proxies use IP addresses that are actually assigned to real people by internet providers like Comcast or Verizon.
Oh.
That's the key difference. When you go through a residential proxy, it really looks like you're browsing from someone's home internet. Websites are way less likely to block these because, well, they look like a regular person. If you're doing something where getting caught would be a disaster like grabbing super sensitive data or, doing stuff on a site that's really locked down, then the higher cost of residential proxies might be worth it.
Gotcha. Makes sense.
Can you imagine any situations where that level of invisibility would be essential for what you're doing?
For sure. If you're trying to get competitor info or access data that websites are really protective of, blending in as a regular user is key.
Exactly.
Now, what about data center proxies? They sound like the opposite of residential.
Yeah, you got it. Data center proxies use IP addresses that come from, Data centers.
Okay.
They're often super fast and can handle a ton of requests, which makes them great for things like grabbing tons of data quickly.
Mm,
But because they're known to be from data centers, websites can sometimes spot and block them if they're trying to stop scraping.
right.
So if speed is your top priority, and you're okay with maybe having to work around some blocks, data center proxies can be a good value.
Hmm.
In your work, would you ever prioritize that kind of speed over being super stealthy?
Yeah, I could see that. Sometimes getting a lot of data fast is more important, even if some of those IP addresses get flagged down the line.
Right.
And the last one they mentioned is mobile proxies.
Right. Mobile proxies use IP addresses that are assigned to, well, mobile networks.
Okay.
So it looks like the traffic is coming from a phone or a tablet. Kind of similar to residential proxies, these are usually seen as legit traffic and often avoid blocks. They can be especially useful if you're looking at stuff specifically meant for phones or if you need to act like you're on a mobile device.
Okay, so we've got a good rundown of the different proxy types.
Mm.
Now, the guide has this table that connects these types to real-world uses. Like if you're just doing general web scraping, they suggest starting with those HTTP, HTTPS proxies we talked about.
Yeah, because they're widely supported and a good starting point.
Makes sense.
If you absolutely need to avoid detection, maybe when you're dealing with like e-commerce sites that are super strict about scraping, they say residential proxies are the way to go, even if they cost a bit more.
Right, right. It's about understanding what you're doing and picking the right tool, even if it's a little pricier. What about if you're building something that needs to constantly pull in, like real-time data, and it's okay if some IP addresses get blocked, as long as you're getting a ton of data quickly?
In that case, they point towards data center proxies as a potentially good solution. That speed can be a huge advantage for real-time stuff, and you can then layer on strategies like switching IP addresses frequently, which we'll talk about later, to deal with the blocking.
Okay, cool. So we know what kinds of proxies there are. Now, how do we actually tell Python to use one of them? The guide uses the requests library, which is like the go-to for web stuff in Python, right?
For sure, yeah. The request library is the standard for making HTTP requests in Python, and it's got great built-in support for proxies.
Awesome.
First things first, you'll probably need to install it if you haven't already. That's a simple pip install request in your terminal.
Okay.
And if you're planning on using those SOCKS proxies, you'll need to grab the extra stuff for that using pip install request socks. Have you used pip before to install Python packages?
Oh yeah, I've used pip a bunch. So once we have requests all set up, how do we tell it to send our traffic through a proxy? The guide has a basic code snippet for HTTPS proxies.
Right. The way you tell requests to use a proxy is through the proxies parameter in your request functions, like when you're using get or post. It wants a Python dictionary where the keys are the protocol, so like HTTP or HTTPS, and the values are the addresses of your proxy servers, including the port number. The guide gives this nice, clear example. Python.importRequests.proxies, http.proxy.apify.com.https, https.proxy.example.com.https, get https.aps.api.ify.org.format.json, proxies, response requests.get, https.response.json. So let's unpack that a bit. First, we bring in the requests library. Then we create this dictionary called proxies. You see, it's got separate addresses for both HTTP and HTTPS traffic. These addresses include the protocol the proxy itself is using, the actual address of the proxy, so proxy.example.com, and the port it's listening on, which is 8080 in this case.
Okay.
Finally, when we ask for something from https.api.ify.org.format.json, which is the site that tells you your public IP address, we hand over our proxies dictionary to the proxies parameter of the get function.
Got it.
When you run this, instead of seeing your own IP, you'll see the IP of the proxy server. It's a simple way to redirect all your traffic. Does that make sense so far?
Yeah, it seems pretty straightforward. It's just a dictionary that tells requests, like, here's where to send the traffic for each protocol.
Right.
Now, what if the proxy we're using needs a username and password? The guide mentions authentication. How does that work?
Right. A lot of these proxy services need you to log in. Requests handles this directly in the proxy address itself. You just stick your username and password in the address using a specific format, like http.username.emailprotected.port or https.username.emailprotected.port. The guide has this example, python.proxies, http.username.emailprotected.8080, https.username.emailprotected.8080, https. You see, the proxies dictionary is the same. The only change is that now the proxy addresses include your username and password before the address and port. Request takes care of encoding all that and sending it to the proxy when it tries to connect. You don't have to do any extra work to log in.
That's really convenient. Keeps the code clean. So we can use a specific proxy, even with a login. But what if we're making a lot of requests? Earlier, we talked about avoiding those pesky blocks. The guide brings up this thing called proxy rotation. Why is it so important?
Proxy rotation is key when you're sending a bunch of requests to the same website. If all those requests come from the same IP address, the website might think you're up to something shady and block you.
Yeah, for sure.
By automatically switching between different proxy servers for each request, or after a few requests, you make it much harder for the website to catch you.
Right.
It makes it look like a bunch of different people in different places are making requests, which, is what we want.
Exactly.
Right.
It's like having a whole team of people making requests instead of just one person constantly knocking on the door.
Yeah, exactly.
Now, the guide gives us this proxy rotator class to manage this whole rotation thing. Can you explain how that works?
Sure. The proxy rotator class is a simple but effective way to handle a pool of proxy servers. When you create one, you feed it a list of your proxy addresses. It keeps track of which one to use next. The magic happens in the getProxy method. Every time you call getProxy, it gives you the next proxy on the list and moves its internal pointer to the next one. When it gets to the end of the list, it loops back to the beginning.
So if we have a list of, say, 10 proxies, the first time we call getProxy, we get the first one, then the second one, and so on, until we get to the 10th one, and then it starts over from the first one.
Right.
Okay, that makes sense.
And the guide also includes a remove proxy method.
Okay.
This is handy for dealing with proxies that stop working or get blocked a lot. If you see that a proxy is causing trouble, you call remove proxy with its address, and it's taken out of the rotation. It even adjusts its internal counter so everything continues smoothly without skipping any of the remaining proxies.
Got it. It's like a little cleanup crew for your proxies.
Yeah.
Now, there's also this thing called session management with proxies, using requests session. What's the advantage of using a session when we're doing all this proxy stuff?
Using a request session is really smart, especially when you're making a bunch of requests, and it works great with proxies.
Okay.
One of the biggest advantages is something called connection pooling. Basically, when you use a session, requests will reuse the same connection for multiple requests to the same website. This can speed things up a lot because it skips the whole process of creating a new connection each time. And when you set the proxy's attribute on a session, those proxies will be used for every request made through that session.
So instead of having to specify the proxies every single time we use requests.get or requests.post, we just set it once for the session, and then all the requests we make after that will automatically use those proxies.
Exactly. This makes your code much cleaner and easier to read. Plus, it makes sure you're consistently using the same proxies for a bunch of related requests. The guide gives us a nice example. Python with request.session as session.session as session. Session.proxies.proxies.response as session.get. https://api.example.com/data2c. The with statement here makes sure that the session is closed properly when you're done with it, so it doesn't use up resources. Any requests you make within this block using session.get or session.post will automatically use the proxies you set in session.proxies. This is also super helpful when you're rotating proxies. You could create a new session with a different proxy for each batch of requests if you needed to.
Oh, that's smart. So we're not just throwing requests out randomly, we're grouping them and being more efficient.
Exactly.
Okay, so sessions help keep things organized and fast. But let's be real. Things don't always go smoothly when you're dealing with proxies. The guide talks about error handling. What kind of problems might we run into?
You're right. Using proxies means there are more things that can go wrong, and we need to be ready for that. The guide points out a few common exceptions you might hit when you're using requests with proxies.
Give us the rundown. What can go wrong?
First off, there's requests.exceptions.proxy error. This usually means your code couldn't connect to the proxy server itself.
Okay.
Maybe the proxy server is down, can't be reached, or just doesn't want to talk to you. Then there's requests.exceptions.connection error, which is a more general error. It just means there's a problem with the connection. Could be between you and the proxy or the proxy and the website you're trying to reach.
So these are mostly about connecting to or through the proxy. What else could go wrong?
You could also get a requests.exceptions.timeout. This happens when your request takes longer than the timeout you set. Maybe the proxy's slow or the network's being weird. And lastly, there's this catch-all, requests.exceptions. Request exception. It's like the parent of a bunch of other errors that might pop up during an HTTP request. It's good to have this one to catch anything unexpected.
Okay, so the guide gives us a try, except block, as a way to deal with all this. How do we use that in our Python code with proxies?
The try.except block is the standard way to handle errors in Python. You put the code that might cause a problem inside the try, and then you have except blocks to handle the specific errors that might happen. The guide gives this nice example, which is a great starting point.
Python response. Request.getURL proxies timeout.response.race for tab.
Proxy connection failed.
A print connection error.
Print request timed out.
Except request.exception. Request exception is eprint, and error occurred.
Here, it tries to get something from a URL using the proxies we set and setting a timeout of 10 seconds. It also checks if the request was actually successful. Like, did we get a good response code? If not, it'll throw an error.
Then we have the except blocks to catch the specific proxy errors we talked about, plus a general request exception for anything else. Inside each except block, you can do what needs to be done, like logging the error, trying again, maybe with a different proxy, or just moving on. By being ready for these problems, you make your scraping and automation scripts much more reliable.
Makes sense. It's like having a backup plan for when things go south.
Exactly.
Okay, so we've got the error handling covered. Now, the guide has this section on best practices and optimization tips. What are some key things we should remember, even if we've got the basics set up down?
Right. Just getting proxies to work is the first step. To really use them well and avoid problems, following good practices is super important.
Okay.
The guide really stresses connection pooling using requests session, which we talked about earlier.
Right.
Reusing connections can really speed up your requests, especially if you're hitting the same website a lot. By not making a new connection each time, things go much faster.
Got it. So less overhead, more speed. What else should we be doing to make our proxy use super efficient?
Setting good timeouts is also crucial. We talked about it with error handling, but you always want to set a timeout for your requests. This keeps your script from getting stuck if a proxy is slow or there's a network problem.
Right, we don't want to be waiting forever for something that's never going to happen. What about the proxies themselves? How do we make sure we're using ones that actually work?
That's where proxy validation comes in.
Okay.
The guide suggests checking your proxies regularly to make sure they're still online.
Makes sense.
You could send a test request through each proxy to a website, is reliable, and see if you get the right response. If a proxy keeps failing, you should probably get rid of it.
Yeah, we don't want to waste time on a proxy that's gone dark. Now, what about being a good internet citizen when we're using these proxies?
That's where rate limiting is super important. The guide talks a lot about adding pauses between your requests. This is crucial for not hammering the website's servers. If you send too many requests too quickly, you're going to get blocked, for sure. Always respect the website's robots.txt file, which tells you how they want bots to behave, and be nice to their servers by adding delays.
Definitely. We don't want to be the reason a website crashes or blocks everyone.
Exactly.
Now, what if a request fails even though we're doing everything right?
That's where you need error recovery. So implementing retries comes into play.
Okay.
The guide suggests that if a request fails because of a network hiccup or a blocked proxy, you should try again after a short delay, maybe with a different proxy from your pool.
Okay.
A common trick is to use something called exponential backoff, where the delay gets longer each time you retry.
Interesting.
This gives the server a break and hopefully lets things settle down.
So it's like, okay, I'll wait a bit longer and try again. Maybe things have calmed down now.
Right, exactly.
These are all really solid tips. Now, the guide also mentions these modern proxy services. What's so great about them?
Commercial proxy services offer a more full-featured and polished experience compared to managing your own list of proxies.
Okay.
They do things like automatic proxy rotation so you don't have to handle it yourself, and geographic targeting, which lets you choose where your requests seem to be coming from.
Yeah.
You usually have a huge network of proxies, and they take care of keeping them healthy and running, which can save you a ton of time and hassle.
So they're like the premium, all-inclusive resort of proxies. We don't have to lift a finger. They handle everything.
That's a great way to put it, yeah. The guide gives an example of a proxy service class to show how you might talk to one of these services. You would usually log in using an API key they give you, and then you can ask their API for a proxy based on what you need, like a specific country. Here's a simplified version based on the guide.python.import requests. I'm typing import dict.def, and itself, apiki.carry.ca.
Self.apiki, 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 iOS apiki, self.disclose, apiki, 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 self.apiki, 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 apiki,
Yeah, especially for bigger projects where managing a ton of proxies manually would be a nightmare. Now, to really show how all this comes together, the guide has this real-world example of web scraping with proxy rotation. Can you walk us through the main parts of that?
Yeah, they have this web scraper class that shows you how to combine proxy rotation, session management, and error handling to build a really solid web scraper. It uses a proxy rotator, which we talked about before, to grab a different proxy for each request.
Okay.
It also uses a request session to manage the connections and make sure all the requests in that session use the chosen proxy. And crucially, it's got that try.except block to handle potential errors and retries the request if something goes wrong, using that exponential backoff we mentioned.
So if the scraper hits a snag, it doesn't just quit.
Nope. If a request fails, the scraper catches the error, prints a message about it, and waits a bit before trying again, maybe with a different proxy. It'll try a few times before giving up on that specific URL. This makes the scraper much more resilient.
So it's like a little web scraping ninja dodging blocks and trying again until it gets what it needs.
That's a great way to put it. It's a practical example of how to use all these best practices we've been discussing. Does seeing it all come together like this help make it clearer how you would actually build something with it?
Yeah, absolutely. Seeing the proxy rotator, the session, and the error handling all working together makes it much easier to understand how you'd build a real application. Now, let's look ahead a bit. The guide mentions some upcoming trends in the proxy world. What's on the horizon that we should keep an eye on?
The world of proxies is always changing.
Right.
The guide mentions a few exciting things. One is AI-powered proxy selection.
Oh, wow.
Imagine a system that uses machine learning to look at how well different proxies are doing in real time and automatically picks the best ones for your specific task. That could make things way more efficient.
That's amazing. So it's like having a super smart proxy manager that just takes care of everything for you. What other trends are they talking about?
Another cool one is blockchain-based proxies.
Oh, interesting.
These are decentralized networks that aim to make things even more private and secure by bouncing your traffic through a bunch of different users.
Okay.
And finally, we can't forget about the rise of IPv6.
Right.
IPv6 gives us a way bigger pool of addresses compared to IPv4, which could lead to more unique IPs for proxies and maybe help with some of the blocking problems we see today.
Those all sound like big changes that could make proxies even more powerful and accessible. Now, beyond the technical stuff, the guide has a section about what developers are saying about all this. What are some of the interesting points they're bringing up?
This is where we get some real-world perspective.
Yeah, for sure.
For example, there's a discussion about whether you always need proxies for every single scraping task. Some devs say that if you're not doing a ton of scraping, just being careful about how often you send requests and following the robots.txt rules might be enough to avoid blocks. What do you think about that? Does it depend on how much scraping you're doing?
Yeah, that makes sense. If you're just grabbing a little bit of public data once in a while, maybe proxies are overkill. But for bigger, more frequent projects, they seem essential.
I agree.
What else are developers talking about?
Another big topic is how cost-effective different proxy solutions are.
Okay.
High-end residential proxies can give you the best anonymity, but they used to be really expensive. Now, though, they're becoming more affordable, which is great.
That's good news.
There's also a discussion about whether those cheaper data center proxies, when combined with good rotation and other tricks, can be good enough for a lot of cases. It really depends on your budget and how important anonymity is to you.
Right. It's all about finding the sweet spot for your project.
Yeah.
Were there any other surprising or interesting things the developers were saying?
One thing that came up, which is kind of controversial, is using VPN services as a cheaper alternative to dedicated proxies.
Okay.
VPNs usually send all your traffic through a single server, so you don't get the same IP variety as a proxy network.
Right.
But some developers are finding them useful for smaller scraping tasks or getting around geo-blocking. However, most people agree that VPNs need more manual work, like switching servers yourself, and they're not really ideal for large-scale automated stuff.
So VPNs might be a decent option if you're on a tight budget and your needs are fairly simple, but they have limitations.
Exactly.
And what's the overall takeaway from all these developer discussions? Like, how do we choose the right proxy setup?
The general consensus is that there's no one perfect solution.
Okay.
What kind of proxy you use and how complex your setup needs to be depends on your project.
Right.
Things like what data you're after, how strict the website is about blocking, your budget, and how big your operation is all matter.
Makes sense.
The key is to understand those factors and make a smart choice, not just use proxies blindly.
This has been a really awesome deep dive. To sum it all up, what's the one thing you really want our listeners to remember?
The big takeaway is that knowing how to use proxies in Python is a seriously valuable skill, especially these days.
For sure.
Whether you're doing data analysis, web automation, or just need to get information online, mastering these techniques will open up a ton of possibilities.
And for those who want to learn even more, we've mentioned a few great resources, haven't we?
Absolutely. The official Python request documentation is your best friend for learning everything about the library.
Okay.
Then there's the HTTP 1.1 RFC 7231 specification, which gets into all the nitty-gritty details of how web communication works. And if you're into the security side of things, PEP 551, which talks about security in Python, is worth a read.
Great. This deep dive has been a real eye-opener. So to you, our listener, what are you going to build with all this new proxy knowledge? What doors does this open up for your data collection and web automation projects? It's definitely worth exploring. Thanks for joining us.